Okay, I guess this one's called the Drake L7. Is a little weird part 2. Even though I'm only dealing with the input and the underneath side today, so the input side and underneath is not that weird. It's maybe a touch different, but it's not really weird. Nothing crazy if you know what's going on. So first thing, this is the bottom cover with the legs on it of the L7, and I guess they did that to give these tubes a little more room and then a little bit of air. You know, the fan is in the rear here, big fan, and there's some room, you know, for the fan to blow down on the tube pins. And then with this design, with this bottom cover sticking out, it can exhaust, you know, air out the bottom. So it's got some pretty good air circulation on the bottom of the tubes, and hence it doesn't have a lot of the tube pin problems that a lot of amps have, because if you don't cool the tube pins, especially the filament, the filaments run on 5 volts, 15 amps per tube. So that's a lot of current, you know, going to the filament. That's the 2 there for the filament. Since this is a grounded grid amp, all you got is the 2 filaments coming in. And you also run the input RF into the filament, one or both. They mix them together and run in there. That's what this choke does. It lets the filament go through. And then you let the RF coming in. There's a coaxial connector somewhere. Actually, it's under there. If you can see that coax connector, which comes from the input board, and here's the 2 here going up to the input board and coming back around and into the tubes when you key down. And then these 3 here are grounded grid. And by the way, this 2-piece amp has a separate high power supply for the high voltage. It's not connected, it's not plugged in. The high voltage power supply is sitting over there unplugged, you know, nothing plugged in, so nothing's gonna bite me. So that's why I'm comfortable sticking my finger in it. Don't do this at home, you know, safety warning. So anyway, it's got that bottom cover, you know, to let the tube pins be cooled. So the Drake L7 here, even though it's fan cooled, it doesn't have the problems that a lot of fan cooled amps have, like the Heat Kit SB220 and the Black Cat JB2000. Both of them have a lot of filament connection and current problems and burning on the 2 filament taps there, because they don't get enough cooling. EMEC recommends forced air cooling for the 3500Zs, you know, with a blower and a sealed underneath and a chimney that blows the air up through the tubes, you know, up through the chimney and through the top of it to cool them. But that costs money, and amplifiers want to make money, so they went to the cheaper fan cooled. But again, if you don't cool them filament pins, you're going to be in trouble. You're going to have issues with them. So first of all, the Drake did that right. Happy with that. Nothing weird about it. Well, it is weird the way they extended that little bottom to do that, but you know, I like that. Nothing, you know, bad about that. Even though the forced air on the Drake L4B is better, but again, everybody is going for cost nowadays. Another thing on a Drake L7, and actually the Drake L4 was the same way, is that the 3 ground pins on the tube were not directly grounded. On this one, this top one, I modified it to directly ground the pins. Actually, both of these on this amp, but the pins are directly grounded. I use some 14 gauge silver plated copper, you know, from the tap to ground. There's a ground stud under this one, and then I added the ground terminal there, just went to the bolt, and over here to the bolt. And same thing on this one, ground stud. This one goes underneath and it's grounded directly, and ground stud. But then on the second one, I started on that one. That one's grounded, but this one is not. This one is factory. And if you look on the net, you'll see a lot of people on this amp, the L4, and I think the SB220 and others. Back in the day, they floated the ground a little bit above ground, which would give you slightly better specs. You know, the specifications on intermodulation, distortion, and all that will be just a tad better if you float the ground. However, it's kind of like any other CB amp. You want a good ground, you got to ground that thing right and use some steel and ground it directly. And they didn't do that back in the day with the amps. They do it now, I think, but back in the day, they like to float the ground a little bit. And if you see that choke there, that choke goes to ground. And then on these two pins, they got a capacitor going to ground. And on that one, they had a capacitor too going to ground. And again, if you look on the net, everybody say, it's not a debate, basically. You want it to be a better amp, more dependable, more solid. Forget about floating the grounds. That's old school. The new thing is to just ground these things directly to ground. Use some, nice stiff metal, to ground them. And it'll make the amp happier, more dependable. With the grounds directed, directly, right? Also, back in the old school, for cutoff bias, when the tubes are in standby, since they're grounded grid, you need to do something for them not to be conducting or producing heat or, operating. And, I've talked about it a lot with the tetrode amps. You got to throw that negative bias, on there. But this is a grounded grid amp. So basically, they throw, in the old days, they threw positive bias on the filament. The grids are grounded directly, right? And the only thing else you got going in is the plate at the top with the high voltage. You can cut that off, but who wants to be cutting on at all 3,000 volts, right? So your other choice in standby, in the old days, they threw positive voltage through there, through a center tap of that, along with the filament and your drive. So in standby, they would throw positive voltage, and they threw 120 volts. And they got that 120 volts by using some very large resistors from the 3,000 plate voltage, and they dropped it using like two 50-watt resistors and then a 7-watt resistor going to ground, and they tapped it right off of the 7-watt resistor, and that made a good bleeder. I mean, it bleeded like crazy because it is sucking down all that heat and everything to make that 120 volts. But you're losing a lot of power. You're probably losing 40, 50 watts. I haven't calculated it, how much power you're using doing that, but and it's doing it all the time, even in standby. That's another 40, 50 watts of heat, and that was in the power supply. So I'm not going to get into that too much today because I plan on doing a power supply one later, with the bias. But nowadays, don't do that. Don't take the voltage off the high voltage and suck it down to 120 and then throw that into the tubes. Nowadays, you just put a resistor in there in the center tap going to ground, and that resistor makes it not be able to pull enough voltage so it will conduct in the cathode. So they put, there are different versions of them. I've seen like 100K ohm, 10 watts. I've seen like 3K ohm, 2 watts in the Black Hats. Whole lot of, variables on that. However, the thing now is just put a resistor from that cathode to ground in the center tap. And that's enough to keep the tubes from conducting in standby. So got 50 more watts off the plate, the high voltage to play with, because it's not going up in heat, even in standby. And it's just a better, safer way to do that by just using a resistor going to ground. But again, I'll go to that later. So getting to the input thing of this thing, and I've said, that at the Drake L7, during the FCC was, cracking down at this time, because CBers were using amps like crazy. And basically, if you don't have some special circuitry to block CBers or 27 megahertz, any amplifier that's made that'll work on 28 megahertz will tune on 27 megahertz, unless you got some special circuitry to block that. And what the Drake L7 did, they did put some special circuitry in there to block that. This is the filter marked on the schematic. I got it unbolted, and they just say, here, low pass filter. This is an original Drake schematic, or a copy of it, and I did highlight that in yellow, and that all that dotted line is the filter, right? Which is this guy. That's one and only sole purpose, is to block or filter 11 meters only. You know how a TVI trap, you can tune it for like channel 2, channel 4, and it'll block that. Well, this filter for the input is tuned for 27 megahertz, and it blocks 27 megahertz coming in. I think I've already told the story a few times. I had a buddy with a Heatkit SB221, and it had a similar filter like this, and it blocked 11 megahertz coming in at his Heatkit. And he used to drive the Heatkit with 500 watts in to get 1,000 watts out, because all that RF was being blocked by this filter here. And he ended up with brain cancer. I lost in touch with him. I don't know if he died, but he probably did. He had brain cancer, and I think it was because of that. And by the way, this is the second Drake L7, and you can see that filter's been taken out. It's been removed. It's gone. And somebody just ran this long coax line over here to the input and over here to the relays to other things. So they ran that one line over there to that, and they removed the filter already on this. On this one, they had left the filter in, and this amp otherwise was set up for 10 meters. I mean 10 11 meters. But somebody left the filter in, so it wouldn't work on 11 meters if somebody tried it. And by the way, this is the amp, if you've seen my part 1, that had that blown capacitor on the plate choke. I don't know if this had anything to do it, where, it had the filter in line or anything like that, but could be. Maybe we'll do more research on that. But one other thing I want to say about the filter is, this is the coax going into it, and that's the coax going out on the right end. And they were originally connected up here to these two points here, and that's, that filter is active. So if you want to remove the filter, you can, take it out like this one, and you can run, one jumper all the way through. Or if you want to do it the easier way, see this second terminal strip right here going across? That's a little 15 picofarad capacitor there, but other than that, there's nothing connected to this terminal strip. So you can actually unsolder it from here where it originally was and solder it there. Unsolder it, was it here? And then move it to there. And then it's just going straight across. That way, if you don't want to, run a whole jumper across there and unsolder it and solder that in and do a little bit of work, you can just Unsolder here, move to here. And where are you? You're behind there, but unsolder behind there, move to there, and you've bypassed the filter. Yeah, that little 4 inches or whatever of terminal strip is not shielded, but hey, 0.001, dB loss. So I wouldn't worry about that. But anyway, that's a cheap, quicker way to do it. Just move your hot terminals on the coax, and I'm gonna leave this one that way, and I'm gonna leave that one that way, and the 11 meter block or filter is bypassed. But if you want to run this amp on 11 meters, you got to do that. Take all the screws out that little cover there and bypass your filter. And again, this one they had not done that, so this amp would not have worked on 11 meters without it. Also, going up here into the input tuning assembly, not only did you have the filter, you had a couple things going up on over here, so you couldn't use it on 10 or 11 meters either. First of all, they had a like a little screw to keep you from turning the band switch to the 10 meter position. So you couldn't turn the band switch, past 15. You couldn't go over here to 10. So therefore, you couldn't actually run it right on 10 meters. But they did a couple other things along with that, because a lot of amps, you can run them on 15 meters too. It'll tune, but it won't be quite as effective. But they will work on 15 meters, a lot of amps. But Drake made sure that didn't happen. What they did is, this is a schematic of that input circuit here, and they didn't put in a 10 meter adjustable slug at all. You just got 10, 15, 20, 40. You got 15, 20, 40, 80, and 160, slugs. You don't have a 10 meter slug in there at all. And even on the 15, Drake took out that one capacitor there, so it would still tune on 15, but it wouldn't tune down to 10. They're like, nope, you ain't gonna get no 10 meters here. So in the schematic, it says for export models only, and hence the export model, the only difference was it had 10 meters, and it had that cap. And also, if you see C7 there in the dotted lines, it had that cap, and that's actually the 10 meter position going across here in red. So first of all, you get rid of that filter, which is here, and then that's the band switch going in, and then it would go to that resistor there that's not there. So you have to actually add that. You have to add that one. And then that's your output of your 10 meters going across. So 10 meter tuning, we've seen a lot of amps that don't have any type of input tuning at all. And then some have full input tuning. But for the Drake L7 on 10 meters with the L7, you're only going to have that one capacitor, and it's not variable unless you put a variable in there. And if you wanted, to add a full 10 meter input, you would have to add one of the tuners there for it. I don't think I'm going to do that if my input SWR is okay once I get this thing up and running. And on this one, they added the caps way underneath. Can't really see it, it's a little bit too dark. Trying to shine some light on it. And this one, it was kind of professionally done, which is interesting because they didn't take out the filter. However, maybe they didn't use this amp for 11 meters. And then on this one, wasn't me, you get things how they are, right? Somebody ran that jumper I was talking about all the way across, and you can see the work that they did kind of melted, and you know, not the prettiest thing. And then that cap there is one they added to the circuit. And then, no, it's not that one. Where did they? Oh, this cap here is added. That's the fourth cap, and I'm gonna try to zoom in and see how they got it going to that wire and coax there. That's kind of yeah. I'll probably redo that one. Don't like that, you know. Don't like that. Don't like that. But hey, I guess they did it. So that's about it. You know, to go to 10 meters, you got to remove the band switch stop, so you're able to turn it to 10 meters. You got to add those two caps, C7 and C8, and you got to get rid of that 11 meter filter. And it's a great idea to ground your grids. Directly ground your grids. It makes the amp a lot better amp. And on this one, it's been modified to get rid of that 120 volts, and actually that resistor there is added into the cathode circuit when you're receiving, so the tubes aren't drawing any power. And when the relay keys down, it actually grounds that out or bypasses that resistor. So that resistor's grounded out, so you can actually get the tubes to conduct. So anyway, I think that's everything I wanted to go through on this side, you know, on the underneath side of the Drake L7. Not that weird underneath, but there are a few tricks, you know, here and there, and I'm still kind of surprised that Drake used that filter, you know, to block 11 meters, even though, you know, they had the band switch blocked, so you couldn't go down to 10 meters, and no input coil, and missing a few caps. So they really tried hard to make it so this amp wouldn't work on 11 meters, but maybe they had to. The FCC was not playing back then. You know, Alpha and you know, a few more manufacturers, they had to do the same thing. Black Cat had to come out with the 10 through 80 meters, and I think after the FCC cracked down some more, that Alpha couldn't even sell. I'm not Alpha. Black Cat couldn't even sell that. All right, that's gonna be it for this one. Bye.